Next presentation on the agenda is a demonstration of the Cosmos 5 architecture from Jason Thomas at Ball Aerospace. We'll be presenting a video of that demonstration, and then Jason will be joining us for question and answers after the video is done. We can go ahead and play that.
Hello, my name is Jason Thomas. I'm a software engineer at Ball Aerospace, and this is a Cosmos 5 architecture and demonstration presentation. A brief history of Cosmos. Cosmos has been used internally at Ball since 2006. In 2014, we open sourced Cosmos with version 3.0. Version 4.0 was released in 2017, which added a config editor tool, command sequence tool, and a new protocol system for delineating packets. Finally, Cosmos 5.0 was just released last year in 2021. It's a new architecture, which is scalable, cloud-native, containerized, and has a new web interface front end. Cosmos is now the default C2 system for all integration and test at Ball Aerospace. In addition, it's used in operations outside of Ball by all the companies you see here. So what is Cosmos 5? Cosmos 5 is the next generation of the Cosmos C2 command and control system. It interacts with embedded software and enables sending commands, viewing telemetry, logging and reducing data, and scripting. Here's a high-level architecture diagram of Cosmos. Cosmos is a containerized system, so Docker Desktop is the primary requirements to get it up and running. On the left, we have external targets, which stream data to and from Cosmos. And on the right is the user interface. The Cosmos user interface is now in the browser, so it's all implemented in JavaScript. That's the primary way users interact with Cosmos. At the top, we have the Redis data store, which we use to store configuration, current value table, data streams. And at the bottom is the AWS MinIO software. It stores configuration, log packets, plugins, and user files. And then through the middle are all the microservices, which we're going to talk about next. So the Cosmos 5 open source edition is broken down into the following containers. We have 6 runtime containers of Redis, again, primary database for all of our real-time data. MinIO is the S3 file server. CommandSlam API is the primary API endpoint to Cosmos. So all the tools talk to Cosmos through this API to get command and telemetry information to display to the user. The script runner API is for our script-related functions. This is what enables our real-time scripting. Operator runs all the Cosmos microservices from the previous slide, and the traffic is the ingress controller and entry into the Cosmos system. We have 2 init containers, MinIO init, which initializes MinIO user accounts and permissions, and Cosmos init to initialize the Cosmos tool plugins and optionally the Cosmos demo. So again, plugins. Cosmos is built around module plugins that are uploaded and installed from Cosmos admin tool. These add additional capabilities to the Cosmos C2 system. You can add targets. These are the things Cosmos talks to. Interfaces, the code that actually allows those types of connections. Routers connecting back into Cosmos from something else, for example, like another C2 system or mission planning. Microservices are user-provided internal processes to run inside the Cosmos environment. You can add new tools to Cosmos, new JavaScript front ends in the web interface, and new widgets for telemetry screen functionality. Plugins can also ask for input during installation, so this allows them to be flexible and used across multiple Cosmos installations. These are the tools currently included in Cosmos 5. We're going to go demonstrate each one of these, so I'm not going to belabor them here. And additionally, we've developed internally a streaming video application player and a CCM viewer. So new in Cosmos 5 is there are 2 versions. There's still the open source edition, which contains all the core Cosmos functionality. It's licensed under the AGPL v3. And we also have an enterprise edition. This adds additional functionality, which we're going to talk about next, and it's licensed by installation and maximum number of connected targets. So what does Cosmos Enterprise Edition get you? The primary feature people want is role-based access control. This is implemented through Keycloak, and it allows for individual user accounts and user attribution for every action performed in Cosmos. You can also connect this up with like an existing Active Directory installation, so you can use all of your existing users. We have pre-built roles for view-only operator and admin, but you can customize your roles to fit the needs of your program. Cosmos 5 has a Kubernetes implementation, so it runs in a cluster and it supports scaling to any number of targets for improved reliability. It supports end-to-end encryption encrypting all data in flight through the Istio system, and it supports scopes. These are multiple configurations on the same server. So let's do a Cosmos 5 demonstration of the tools. So the first tool I want to show you is the Command Telem server. This is the entry point, if you will, to the Cosmos system. It gives you status information about all the different interfaces you have and the targets that they're connected to. You can manually connect and disconnect a target. You can see how many bytes have been sent, received, the command and telemetry packets. Down here is log messages. So you can search through this and just display the error log messages. Again, this is a Cosmos demo, so we're constantly streaming out different events and errors so you can see different things happening. It lists all the different targets that are available in the system. Again, all the command packets sent. One of the nice features about this is you can view the raw data of each command packet, so you can debug the exact bytes that were sent. It shows you the exact same thing for Telem packets. Again, showing the raw data here, it gives you the ASCII representation. You can pause this to investigate, individual bits of a packet that you're trying to determine, is this the right thing? It displays the routers in the system, of which we have one in this demonstration and a status page for the limit sets. The limits monitor tool displays all of the events related to limits. And so as things go in and out of limits, they're displayed on this limits bar. This shows you where the red, yellow, and green limits have been defined in your system. So for this temperature 1, you'll notice we're scrolling back down into this operational range of limits. This is the sweet spot where we want to be. But limits can scroll in and out. This one, temperature 2, is up here at red. You probably want to take some action there. But what's nice is this allows you to see the trend, and as this thing is getting closer to yellow, that allows you to take preventative action before you actually get into the bad limits. It also keeps a log of all the limits that are happening chronologically. In addition, you can use some of these buttons to display or hide a limit if you know potentially this is just a bad wire or something's out of limits. That's okay for this particular test. The command sender tool allows for sending one-off commands to any target in the Cosmos system. So I can send an abort command and it shows up down here as history. This command was sent. If you have a command with parameters, you get this nice table which displays all the different parameters in the command. This one I can send a normal collect with duration 10, and if I click send, this again goes down into this command history. What's nice about this too is it allows you to then modify a command and resend it right from this command history. The script runner tool is our real-time script running system. It alerts you to how many scripts are currently running, 0. I'm going to open up an existing script. It goes down into the targets and looks for procedures. So if I select this collect script and run this, basically what this is doing is it's running it in the back end and then telling the front end which line number we're at. So there's dialog boxes like this that allows you to enter numbers. There's choice boxes. Click OK. Special collect. The special collect is hazardous. Do I want to send that? Yes. And clear is hazardous. Do I want to send that? Yes. And now the script is stopped. It's complete. When you're done running a script, you get this script log about all the different things that were happening in the script, all the different commands that were sent, the checks that were issued, what the user inputted throughout all the script that was running. You can download these, and this also goes into the backend MinIO server. All of this stuff is logged. Packet Viewer is a way to display your telemetry with no real effort on your configuration. Once you've defined all of your telemetry packets, you get Packet Viewer for free. So in this ADCS example in the telemetry in our demo, we can go down to one of these things and I can get details about this, and it shows you these are the raw values, the converted values, the formatted values, values with limits. An even better example is the health and status packet, because this has a temperature which has a different raw value, converted value, formatted value. Here's the conversions that are applied, polynomials, it's in Celsius units. These are the limits. So it gives you an easy way to see all the different telemetry points in your system without really any configuration work on your behalf. Telemetry Viewer is also a way to view telemetry, but in this you're building up little screens. So here's an example of the health and status screen. Again, I'm showing like these limit bar views. So this is showing you as the limits are moving up and down. In the demo, we have deliberately set limits to infinity and -1 or divide by 0 and things like that in order to show what happens when that happens. You can allow yourself to have buttons on your screen so you can send collects or do whatever you want. This allows you to bring up multiple screens. So if I bring up this ground screen, this is actually using like images to show which antennas are connected to the satellite at any given time. You can drag these screens around and minimize them. And then also remember, this is a web browser. So if I want, I could just open up a new tab and display additional screens over there. Telemetry Grapher is a real-time graphing system. So if I pull up the ADC, actually let's pull up the health and status and do those temperatures again. That's always good for the demo. Temperature 1, it's just going to start graphing that. If I pull up temperature 2, temperature 3, and temperature 4. You'll notice that there's a graph up here of all the telemetry points. I can expand this out to take up the whole screen. And this is an overview graph. So as these things are getting graphed, you get this long overview that's easier to see as the graph is expanding. If I drag onto this, the graph automatically pauses and I can see what the values are. You can see as I'm moving the mouse, I'm getting mouse overs down here. You can also hide individual graphs if you want to have this scroll, like, okay, now I can see that this is auto scaled to this particular telemetry item. I can see what's going on. If I add these back in, I can continue on with the real-time graph, and as you can see, it's built up some history now. There's a lot of really cool things you can do with Telemetry Grapher. Data Extractor is a way to pull data out of Cosmos and extract it into CSVs, for example, to use in like Excel to do additional analysis on. So if I have been running, for a couple minutes, we'll just do a couple minutes, and then I can say, okay, I want to view all of the health and status packet items. So I can add this entire list of items down here. And then if I say process, it's going to calculate, or it's going to pull out all the data from that time period and then build me this CSV. The data viewer tool is an interesting tool. It's used to display data that's not as easily represented with like a key value pair. A good example of this is like a memory dump, but we can also show it just with a simple packet that already exists, like this ADCS packet. So if I just click start, I'm going to start seeing this data come in. And if I expand this thing out, this is the real-time ADCS packet coming through. You can see the bits are all changing. I can pause this thing and scroll back in time, look for the data I'm looking for. So that's also what's nice about this tool, is it gives you this like history of all the packets coming down. So you can see this would be also useful for like an event viewer. You get all the individual events coming down, or again, like a memory dump. In Cosmos 5, there's a new tool called Timeline. This allows you to set up timelines, so events that can happen in the future, and either run commands or run scripts. I've set up a simple like antenna timeline. If I select these things, you can see them both together. It also allows you to view them as a calendar view. So coming up at 10:30, I have a contact for antenna 1, and then at noon, I have a contact on antenna 2. Things like that. Finally, the admin tool. This is where, and again, this is limited to the administrator, this is where you add new functionality to Cosmos, uploading plugins. So plugins are what configure all of these different tools. You'll notice all of the Cosmos tools are actually implemented as plugins. So you can add and remove those and upgrade those. I've now launched the Cosmos Enterprise Edition. So the first thing the Enterprise Edition forces you to do is to log in. If I log in with the admin user, I can demonstrate some of the administrative functions, like scopes. So now logged in as the admin user, this is my username, admin, and I can demonstrate building a new scope name. So let's say you have a software test bench, SWTB. So we'll add that as a new scope. The new scope won't have any functionality. If I do a quick refresh, you'll notice up here the scopes now changes from simply grayed out default to default and software test bench. If I switch over to this software test bench, it will show me that under the plugins I have nothing installed. So I'm going to go ahead and install the Cosmos Demo plugin. When I upload this, it prompts me for all the different variables that I can change. So all these target names, interface names, things like that. If I just put a SW underscore in front of a few of these things, just to demonstrate that this will show up as change, we'll do the interface name of these targets. That's going to show this is our software test bench. I mean, in reality, you'd probably want to change a whole bunch of different things. So I'm going to let that upload and install, and in the meantime, I'm going to log out of this admin user and log in as an operator role. Typically, you're not going to be running as admin. This is just to install new tools. The operator role has permission to do all the things an operator might want to do, send commands, run scripts, things like that. Right, so I'm in the software test bench scope. Let's switch back to default. And if we go to the command telm server, then you'll notice it looks exactly like it did before. These are our standard group of 4 target or interfaces. So it says new microservices are detected. This thing is just going to keep going and installing. Again, this is all running in Kubernetes. So if I bring up this command window, I can show you in like kube control git deployments, for example. And there is a large list of deployments in this case. Expand this out. So here's the list of all the deployments that happened in this Enterprise Edition. You can see it scrolled by, and now that we have 2 scopes, there's a lot of stuff running on there. Again, this is kind of why my laptop's struggling a little bit. So if I come back here, you'll notice that, yeah, we're starting to, list and identify these new microservices, these new interfaces. Here's our SW-inst2. If I go over in the targets, it doesn't appear like that's all populated yet. Again, it's still processing. There it goes. So I've got my new software, software test bench target, and they're mapped to these new interfaces. So we've created and uploaded a brand new set of microservices to this new scope. And then switching in between scopes is as simple as just dropping down this menu option and going back to the default scope. This refreshes everything, and now basically you're on this new scope and you're talking to new targets, potentially. So that's a demonstration of the Cosmos Enterprise Edition. Cosmos 5 provides a cutting-edge, containerized microservice-based web interface command and control system. Its plug-in architecture makes for a very highly modular system which allows you to upgrade and install new tools. The architecture is cloud-native and optimized for scaling, especially the Enterprise Edition, which runs in Kubernetes. It's easy to use and configure. A lot of our configuration files are simply just text files, which integrates into easy configuration management control. And there's an open source and Enterprise Edition available for the first time. Learn more at cosmosc2.com. Thank you.
All right. Thank you so much, Jason, for the wonderful demo. Looks like we do have some time for questions, and plenty of them have been coming in over the course of this. So I'll ask the first one that did show up on chat. What is the scripting language used for Cosmos?
The scripting language is Ruby. You guys hear me all well?
Yep, can hear you just fine.
Yeah, I can't believe I didn't mention
that. Next question from Dave McComas. Is the 5.0 command and telemetry definition language similar to 4.x? If not, are there 4 to 5 translation tools? And finally, is there an external command and telemetry API?
Yeah, so we kept the command and telem definitions identical to ease that whole transition process, including like the screen definitions. So that's all the same. And the second part was, is there, yeah, so there is, on the command line, there's the ability to migrate like an existing 4 into a new plugin structure. So that's like a command line option to do that. And is there an external API? Yes, there is. In fact, we actually have a Python interface to our Cosmos 5 system that's underneath our GitHub account at Ball Aerospace. There's a Python API. So if you prefer Python over Ruby, Python is not implemented in our like script runner tool, so it doesn't natively understand that, but you can write like external Python programs.
Okay, great. Next question from Tim Canham. Does Cosmos have the notion of non-scalar or i.e. a struct for telemetry definitions?
We have an array item that you can declare. So basically, yeah, otherwise we allow you to pull in like what we call partials. So you could have, and a great example of this is CCSDS, right? So you have a CCSDS header on everything. You define that thing once, and then you can pull that into all of your packets and just say, hey, render this header. And that's part of our demonstration. So.
Okay. Next question from Daniel Brown. What is the maximum telemetry rate supported?
Oh boy, that's tough because it really comes down to like hardware and your network and stuff. We've definitely run, 10 hertz stuff all the time. I think people have run 100 hertz. It really comes down to the hardware and that you're dealing with underneath it.
Okay. Next question from Isaac Rowe. Do you have build and install instructions available for using Cosmos 5 in environments where Docker may be unavailable?
Docker is a requirement, so that's sort of the foundation of Cosmos 5. We do have install instructions for a air gap environment because we've gotten it up and running in C2S, so that's definitely part of our install domain. But you do need Docker.
Okay. Next question from Alan Cudmore. What are the system requirements compared to the older Cosmos architecture? I've been able to run earlier versions of Cosmos on a Raspberry Pi. Is that still possible?
That's interesting. We actually had somebody recently at Ball run it on an embedded ARM device too. But typically you're going to be running this, full up, right? Docker is a fairly significant requirement. You want a lot of RAM, honestly, in order to build and have different targets connecting. So I run it on my laptop all the time with 16 gigs of RAM, but if you're running it for a big installation and it's really a RAM requirement because Redis is in the background soaking up memory. It does stabilize after like an hour or so, but yeah, RAM is really more the limiting factor.
Okay. Next question from Luis Rodriguez. Is Docker a requirement or just the Docker images? Could this be run in something like Podman using the same images and Docker Compose files?
Right. Yeah, that is true. We run it so on Windows, Docker Desktop's the easiest way to get up and running. Probably the same for Mac OS, but yeah, I know CentOS, even our IT people are really excited about moving to Podman. Everyone knows the Docker licensing changed, right? If you're in a big enterprise, you have to pay a license now for Docker Desktop. So yeah, but it's just container based. So right, on Linux, Podman.
Okay, great. And we're out of time. We have a couple more questions left that we'll move over to the Slack if you're interested in continuing the discussion over there. Thank you so much, Jason.
Sure will. Thanks.